Dear students, in the last class I have explained the introduction to the oscillation, in which we have learnt one of the important type of oscillation, which is a simple harmonic motion. Example for simple harmonic motion: oscillating pendulum, vibrating strings of the musical instrument, vibrating air column in an air column instruments like flute. Now, what is the equation that represent the displacement of a particle whenever it executes a simple harmonic motion? The equation is given by y is equal to a sine omega t. Y is equal to a sine omega t, or it can be even y is equal to a cos omega t. So, let us assume that the equation that represent the displacement of a particle. If the particle is here initially, this is called the mean position. Mean position. And this particle, if it vibrates upward and then comes to the mean position, and again it goes downward and again it comes to the mean position. Now, these are called as extreme position. So, from the mean position till the extreme position, the displacement is denoted by A, and that is called amplitude of a vibration. So, what is amplitude of vibration? Maximum displacement from the mean position, correct? Or that is basically the distance between the mean position and the extreme position. This is A. This is also A, but since it displacement is a vector, we write minus A, negative direction. This is positive direction, this is negative direction. So, that is A. What is Y? Y is the displacement of the particle from the mean position at any instant time t. So, t is the time and y is the displacement. For example, from here till here, so this can be y. What is the maximum value of y? Maximum value of y is A. So, y minimum value is 0 when it is at the mean position, and the maximum value is A when it is at the extreme position. So, therefore, the value of y lies between 0 to A or 0 to minus A. Minus A means in the downward direction. So, this is a trigonometric function, and omega is called angular frequency or angular velocity, which is given by omega is equal to 2 pi f, or that is also equal to 2 pi by t. So, we have used that equation in chapter rotational motion, or even in uniform circular motion, where f is the frequency, t is the time period. How do you define frequency? Frequency is the time taken by the particle to complete one vibration. What is the t? Time period of oscillation. Time taken by the particle to complete, time taken to complete one oscillation. What is the frequency? Number of oscillation, number of vibrations completed in 1 second. Whereas time period is a time taken to complete one oscillation is called as a time period. So, this is important equation. Now, from the displacement from this y, we can find the maximum value y max, and we can find a minimum value. So, y minimum. So, y minimum is 0 and y maximum is A. So, whenever we know the displacement, we can find the velocity of the particle. How to find the velocity when we know the displacement? For which we have to differentiate this. So, it is a dy by dt. That is a d by dt of y is nothing but A sine omega t. So, A is constant. A is constant here. It is now differentiation of sine omega t. So, that is V is equal to A into differentiation of sine omega t is cos omega t into differentiation of omega into t. Okay, it is a successive differentiation. So, sine omega t. So differentiation of sin omega t, where omega is a constant and differentiation of t with respect to t is 1. So therefore the equation, so this is the equation for the displacement. So equation for the velocity is a omega cos omega t. We also know that cos omega t is nothing but square root of 1 minus sin square omega t, correct? Cos omega t is root of 1 minus sin square omega t. So we get that from sin square x plus cos square x is equal to 1. So I can replace here, it's a omega, cos omega t is nothing but root of 1 minus sin square omega t. So you take a within the root, so I'll get omega into root of, when you take a within the root, it becomes a square minus a square sin square omega t. But what is a square sin square omega t? That is nothing but y square, because y square is nothing but a square sin square omega t. So therefore, so equation for v, one of the equation is this, a omega cos omega t. The other one is omega into root of a square minus, this is nothing but y square, correct? Y is here, so square of it is this. So these are the two equations for the velocity. There is the equation for displacement, there is the equation for velocity. So displacement is y is equal to a sin omega t, whereas velocity is a omega cos omega t or omega into root of a square minus y square. So here we can find what is the maximum, minimum and maximum value. Okay. Now at the mean position, okay, so what is the value of y? Y is a 0, correct? No? At the mean position, y is 0. If you substitute y 0, this term becomes 0, you will get root of a square, which is a, so you will get omega a, and that will be maximum value. So at the mean position, velocity is a maximum. At the extreme position, correct, displacement is a at the extreme position. So substitute y is equal to a. When y is a here, you will get a square minus a square, you will get 0. So velocity is a minimum. So velocity is a minimum at the extreme position. This is at the extreme position, and velocity is a maximum at the mean position. So all these equations you need to remember, because there are numericals based on this for all form of exam. So that can be board exam, or it can be even for competitive exam as well. So we have derived expression for displacement, we have derived expression for velocity, and using the velocity we can get the expression for kinetic energy, because any moving body possesses kinetic energy. So what is the equation for kinetic energy? K is equal to half mv square, and v is here, correct, half m into v square. Square of this will give you the equation for kinetic energy, which we will write later. So now once we know the velocity, we can find the acceleration, correct. So how to find the acceleration? Acceleration is rate of change of velocity, dv by dt. That is a differentiate the velocity. So velocity is here, a omega cos omega t, a omega cos omega t. So a omega is a constant, so we get d by dt of cos omega t. That's a omega. Differentiation of the cos x is minus sin x. So minus cos omega t into differentiation of omega t again. So where omega is a constant and differentiation of t is 1. So therefore what we get here is a is equal to minus is here, a omega square, and then we have differentiation of cos omega t is a sin omega t here. Okay. So a omega square sin omega t. So that is the equation for acceleration. A is equal to minus a omega square sin omega t. But look at the expression here. A sin omega t, a into sin omega t is nothing but y. So therefore, what we get here is minus omega square y. So this is the expression for acceleration. A is equal to minus a omega square sin omega t, or that is equal to minus omega square y. At the mean position, correct, y is 0. When y is 0, a is 0. At the extreme position, y is a. Therefore, a is equal to minus omega square a. So this is the minimum value and this is the maximum value. Okay. Magnitude, if you take magnitude of the acceleration, is omega square a. So therefore, acceleration is a minimum at the mean position and acceleration is a maximum at the extreme position. Understood? So this is the expression for acceleration. And once you get the expression for acceleration, we can write the expression for the force, because force is nothing but mass into acceleration. So therefore, F is equal to minus m into this a omega square sin omega t, just multiply by the mass, okay, and that's equal to minus m omega square y. So that is expression for force, which is also called as a restoring force in the case of simple harmonic motion. So just like earlier, at the mean position y is 0. At the mean position y is 0. Therefore, force is also minimum, that's a 0. At the extreme position y is a, therefore force is a maximum, which is a minus m omega square a. So these are the equation for the force minimum and maximum value. So hope you all have understood the derivation part of it. And now let us write three expressions for the energy. Due to the movement of the particle, it possesses kinetic energy. The velocity is given by the equation v is equal to a omega cos omega t. Therefore, kinetic energy is a half mv square. The other equation is omega into root of, it's a square minus y square. So half mv square, half m square of this, okay, so you'll get a square omega square cos square omega t. That's k. That is also equal to half m square of it, so you'll get omega square a square minus y square. So this is the expression for kinetic energy. So at the mean position y is 0, correct, at the mean position y is 0. So when y is 0, so this term becomes a 0, so we'll get half m omega square a square. At the extreme position y is equal to a, amplitude. So when y is a square minus a square becomes 0, so k becomes 0. So therefore this is the maximum kinetic energy possible and this is the minimum kinetic energy possible. So kinetic energy is maximum at the mean position and kinetic energy is minimum at the extreme position. Now since there is a restoring force, it also possesses potential energy, which is called elastic potential energy. And that elastic potential energy is given by U is equal to half k y square, which is half k is nothing but minus f by m. okay, sorry, F by y, because the restoring force F is equal to minus K into y. So, K is equal to minus F by y into y. So, one of the y will get cancelled here. Now, we can replace the expression for force, half. Expression for force is m a omega square sin omega t. Expression for displacement y is equal to a sin omega t. So, therefore, equation for energy is a half m a square, here it is a into a square, omega square, and then sin square omega t. That is also equal to half m. See here, a square sin square omega t. A square sin square omega t is nothing but y square, correct. So, therefore, we can write it's half m, and then we have omega square and then y square. So, this is the expression for potential energy stored in a particle vibrating or executing simple harmonic motion, half m omega square y square. So, even here at the mean position y is 0, and when y is 0, u is 0, so that is minimum, and at the extreme position y is equal to a. At the extreme position y is equal to a. When y is a, you will get u is equal to half m omega square and a square. Okay. So, that is the expression, and this is the maximum value. So, what we get to notice from here, if you compare this one, at the mean position kinetic energy is the maximum, but potential energy is minimum. At the extreme position, kinetic energy is minimum, whereas potential energy is maximum. How to find the total energy? So, total energy is sum of potential energy, kinetic energy and the potential energy. So, if you add these two equations, so let us take this one. So, here half m a square omega square, here we have half m a square omega square. Here we have cos square omega t, here we have sin square omega t. So, therefore, what is common here is half m a square omega square, and the term within the bracket, because this is common, right? This is common. What do you get within the bracket? You will get cos square omega t plus sin square omega t. Sin square omega t. So, that is nothing but cos square x plus sin square x, which is equal to 1. So, therefore, the total energy is always constant, which is half m a square omega square. Even if you add these two equations, this one, half m omega square y square and then half m omega square minus y square, they will get cancelled, and you will get the total energy as half m a square omega square only. So, therefore, there are basically equation for displacement, there is velocity, there is acceleration, there is force, then we have kinetic energy, we have potential energy, and then the total energy. So, altogether total 7 equations are there, and all the equations are again important, the numericals of which are important. So, very quickly I will list all those equations in one single table, so that it is easy to remember. So, equation first one is for the displacement, and for displacement equation is y is equal to a sin omega t. So, whatever that we write here is at the mean position, and whatever that we write here is at the extreme position. So, at the mean position y is 0, which is minimum, and here at the extreme position y is a maximum, which is a, and that a is called the amplitude. Next, we get equation for velocity. If we differentiate, you will get the expression for velocity. There are two equations, v is equal to a omega cos omega t, that is also equal to omega into root of a square minus y square. And at the mean position, y is 0, but velocity is maximum, which is given by a omega. And at the extreme position, y is a, if you substitute y a here, velocity becomes 0. So this is minimum. And once you get the velocity, it's very easy to write the expression for kinetic energy. So I'll write here itself. This is for kinetic energy. So kinetic energy K is equal to half mv square, half m v square, square of it. So this will be a square omega square cos square omega t, that's equal to half m and square of it. So we'll get omega square into a square minus y square. And kinetic energy is maximum, which is half m square of this. So a square omega square. And here kinetic energy is a minimum, which is 0. So using velocity, it's easy to write the expression for kinetic energy. Next, we'll see acceleration. Acceleration A is equal to differentiation of the velocity. So I'll get minus a omega square sin omega t, that's equal to minus omega square into y. At the mean position, y is 0, so acceleration is also 0, so minimum. So magnitude of the acceleration here, when y is a, we'll get omega square a. So that's maximum. I've taken the magnitude, that's why we are not using the sign. And once you know the acceleration, we can always write the force, because force is nothing but mass into acceleration. So force is equal to mass into acceleration, which is minus m a omega square sin omega t. That's equal to minus m omega square y. When acceleration is minimum, force is also minimum. When acceleration is maximum, force is also maximum, which is m omega square a. And once we know the kinetic energy, we can write the potential energy, which is again complementary of it. So potential energy is half m a square omega square. Instead of cos square omega t, we get sin square omega t. That's equal to half m omega square and then y square. See that a square sin square omega t is nothing but y square. When kinetic energy is maximum, potential energy is minimum, that's a 0. And when kinetic energy is minimum, potential energy is maximum, which is half m a square omega square. Then finally we have expression for the total energy, that is E is equal to half m a square omega square. And it's a constant, so that's why whether it's at the mean position or at the extreme position, the total energy remains constant, half m a square omega square. So this table of equation is important, especially for the numericals, so which we are going to solve in the next class.